Okay, hello everybody. I want to welcome you to our first Tuesday of every month webinar here at Michigan CNC. And today is March the 6th. And our guest instructor tonight is John Hennen from Legacy Woodworking CNC. And what I'm going to do is I'm going to turn control over to John, and I'm going to let him go ahead and run with it. Okay, John, I just pass control over to you.
Okay.
So hopefully your screen will come up.
Okay, my screen is now being
everybody's
shared.
screen isn't large. What you have to do is you have to hit the enlarge, the screen button. Make it big.
Okay, has everybody got their screen big and ready to rock and roll?
Yeah. If you're not talking, turn off your microphone.
Perfect. Okay, with all these bubbles over here, I'm gonna make it so that my screen is gonna be just up to the bubbles, but not quite not overlapping them, just so that we can still see them but not have them in the way. All right. Well, I got it's my pleasure to be here tonight. I'm really excited about this one. I first met well, I've known Don Batts for a very long time, and Don been pestering me for a while to come out to Michigan, and I came out to Michigan, and before then I got to meet Ted and Don both out over in Connecticut, and it's been a fun time as we've got together and been able to share our passion for CNC and everything else, and just a really cool group of guys. And anyway, so it's my pleasure to be here tonight, and we are going to talk a little bit about vacuum tables, and we're going to actually design and build one. A lot of times when we think of CNC, we think of it for a couple different things. We're thinking about making either signage, or we're going to make just wood signs, or we're going to make kitchen cabinets, or we're going to make cribbage boards, or small things like that, because we don't have a full 4x8. But there's some wonderful other materials we can use, and so we're going to build a vacuum table tonight that's going to be able to be used with a drag knife as well as your regular router bits and for wood cutting. With a drag knife, it adds to you the ability to now use vinyl, cut paper, cut the foam core, cardboard stuff for making model airplanes and models, as well as cutting leather. In fact, I do a lot of leather cutting, which is really fun. Anyway, so we're going to build a quick vacuum table, and Ted asked that I build it in a 2-foot by 2-foot area. Now, and understand that we're going to build it that big, but you can make it as big as you want it to be. And what we found over using it is I used to make my vacuum tables out of MDF, but it's very porous, and so instead I now make it out of melamine, and then I'm actually going to paint the edges with an acrylic paint, something to seal off the edges. And so we'll get into that as we build everything. So to begin, I'm going to use a spire. I will also save these as a VCarve file, and Ted can as well. He has all the copies of all this as well already, and he can save them as a VCarve file as well. And so but because I have a spire, I will use it. A little bit about myself. I've been with Legacy since 2001. I used to work in the shop, which is where they used to build machinery, and now I do all the sales. I last did my biggest presentation I've done in a long time was down in Las Vegas for the Vectric User Group meeting in Vegas. Really excited about that one. They asked me to come back to Chicago, but unfortunately I'm going to be out of town that weekend, so I apologize. I wish I could go out there. I know. Everybody's giving me the big thumbs down on that one. One of the projects, and Ted's already seen this, so it's not new for him, but this is one of my recent projects. I drew, this is the Budweiser Eagle. This is, this gentleman over here on the left-hand side of the page stands 6 foot 4 inches tall, just to give you an idea of the scale of this piece. This guy's as tall as I am, a short 5'8". This is about 9 feet by about 11 feet, and it's 12 inches thick. This was cut in 6 separate pieces and then put together, and it is now hanging inside of the Anheuser-Busch distribution plant in Baytown, Texas. It was a really fun project to work on. Unfortunately, being that it's Budweiser, I can show you all pictures, but this is all you'll see. It'll never be on Facebook. It'll never be anywhere else. Vectric asked if they could put it in their newsletter, and unfortunately, Budweiser said no. So it gets to stay here, and you guys get to see it, and that's about as far as it ever gets to go. It's all painted now and looks really wonderful. They're doing their open house this Friday, and unfortunately, I did not get to fly down to that one. And so they're going to send up some cool pictures, and I guess if I drank, and I don't drink, they were going to send me up a couple of kegs. And I said, that's wonderful, but I don't drink, so it doesn't help me any. Anyway, let's get on with our drawing. If you have any questions at all during this, you know, keep them written down, and then Ted will give us time for questions, and we'll go from there. So to begin, we're going to just start over here, and we're going to just create our new file. And we're going to create it a 24 by 24 by 3/4 of an inch thick piece of material. This is going to be our actual vacuum table. And I'm going to put my 0 up on the top on my material surface. I like it there. And then also in my bottom left corner. Now, feel free to put it wherever you want to. This is just where I like to put it there. Modeling resolution, this doesn't really matter in this case because I'm not going to do any 3D modeling, but I just have my default at high, very high, and then I go ahead and hit OK. All right. So to begin with our vacuum table, we're going to start by creating a square. We're just going to use this guy here, draw a rectangle, and we are going to make this one a 22 by 22 inch square. And we're just going to do square corners. We're going to create it right there. So there is our square piece here. And now that's going to be the outside perimeter of our table. And then we're going to take and use our draw line tool, our draw polyline tool, and we're just going to we're going to snap this point here at 1, 1, and we're going to come over and we're going to snap again at 22. So here is our first line. We're going to simply use our array tool. We're going to go every 2 inches. So if we're 1 inch up and we're 1 inch down, we got 22 inches between here. So we should go 11 copies. So we'll use this to array copy, and we're going to go in the X1, which means we're not going to go this direction at all. We're not going to go to our right. But in our Y, we're going to go up 11 times. And we're going to put a gap between of 2 inches. Now when we do this and we click on our copy, it's just going to lay those all out just like so. Well, there we are. We'll click on close, and then we're just going to delete this extra line, our original line right down here. It's kind of hard to see, but you can see here how it's pink with a black line underneath it. That's our original line. We're just going to go ahead and hit delete to get rid of that one. We're then going to select these, and so if we click with our left click and we drag up and to the left, anything it touches, it selects. Okay. If we're dragging down and to the right, it won't select anything because that's everything around it. So we have to go like this to get everything, and then it will select. So up and to the left is touching, down and to the right is surround. Once we have these guys, we're going to copy and paste. We can do that up here by copy and paste. And then we're going to use our rotate button right here, or we can use the shortcut key of 0 on our keyboard and hit that twice. So it's totally up to you on however you want to do that. But we're going to rotate that out so we have our nice grid right there. Okay. Now, everything from here. Yes, go ahead.
I just want to ask before we get too far along, is the screen keeping up with his voice? Because at times we've had lag. Is everything okay?
It's okay here.
Okay. All right. We'll continue on. You might just want to give just a second for the screens to keep up with you.
I'll do that. Okay. So one thing about me is I go a million miles a minute. If you've ever met me, that's like my whole life is a million miles a minute. So I'm going too fast. Please say, John, slow it up a little bit. And don't worry, I don't feel bad about that at all. You can say, John, slow down, or whatever you want. No problem. Okay. So from here, we have our grid. We have 2-inch squares everywhere. And when I first started making vacuum tables, I used to draw a square and array it out. But then it took forever because I would cut around each square. And that just is not a good idea. And so by drawing these lines out, it cuts a lot faster. And that was just learning curve on my part. Okay. Now, the next thing we're going to do is we're going to set up our toolpaths for the grid. And in order to do that, we have to know what we're putting inside our grid. And so one of the things that we did is, and Ted actually found this for us, which is fantastic. It's this gasketing material. This will be in an email that he's going to send you, but we'll just go ahead and open it up. This is the gasketing material. It's a 1/4 inch wide, and it's 5/16 tall. And so what we know by that is I want the gasketing material to seal nicely, but I don't want it to bulge up above our table. And so in this one's case, being that it's 5/16 tall, we're going to cut it at a 1/4 inch wide by a 1/4 inch deep, leaving a 1/16 proud, so that when it comes down and sits on these little squares, we're not going to have a bulge where any of that gasket is, but it's going to be compressed enough to give us a really nice seal. This stuff is $52 a roll, and in a roll, Ted, how much is in a roll on this one? I thought I remember 75 feet or something. Yeah,
75 feet.
75 feet. So a roll will last you forever. Great stuff. I called them up about it. It is a closed cell foam.
You might want to even, a couple of you may split a roll or something.
There's a good way to do it, is splitting a roll. That's for sure. Okay, so let's go ahead and then lay out this portion of it. So we're just going to use this little button here to switch to our toolpaths over on this side, and we're just going to select everything. So we're just going to drag down, or a Control A will also do that. We're going to use our profile toolpath. That's this one right here.
Okay, John.
Uh-huh.
When you are switching between your pictures and the screen, that's when we have the lag.
Okay, I'll wait for just a second before we jump into this one. So after we've selected everything, we're going to go to our profile toolpath. Okay, that's this first one up here in the top in the toolpath operations. And we'll set up our cut depth for our 1/4 of an inch. That's going to give us our depth of cut. And then, of course, our width of cut is going to be determined by our cutter. So we're just going to make sure that we're using a 1/4 inch end mill for this one. Now, in this one's case, I prefer that you use an upcut spiral because we're going to also use this same cutter to drill some holes in the top of our table. And so we want to be able to eject those chips out. Using a down cut will work, but it will burn up your hole a little bit. And so an upcut would be preferable on this one. Okay. For now, we're going to leave our feed rate and our plunge rate pretty conservative. And then you can modify that one as you see fit to fit your machine. Different machines have different feed rates and recommended feed rates, so we're going to go ahead and do that one. And we are going to slow our spindle speed down just a little bit to about 15,000. We'll go ahead and hit apply and OK. And then we're going to come down here to our machine vectors tab. We're going to be on the vector, which means our cutter is going to be chasing those vectors. All right, and we'll go ahead and click on calculate, and that should give us this right here. Preview our toolpath, we get a nice little grid. Let me roll this up here so you can see how we have a nice grid that's set up going around our perimeter as well as on these squares. We want the squares there because I still want to support that middle section. A lot of vacuum tables I've seen have big open areas, and the problem with the big open areas are that we get a little bit of a flex depending upon the strength of our vacuum. In this one's case, Ted's going to be using his Festool vacuum for it, and that has quite a bit of suction, and I don't want it to flex the waste material above it, and so we want to make sure that we have enough surface area here to hold all that up. All right. The second toolpath that we're going to put in here is we're going to cut out the hole for the vacuum. Now, you can just use your regular shop vacs. If you're going to use it for a long period of time, then make sure that you get a shop vac that has a secondary cooling fan. The larger the Festool does, I know that for sure, as well as the fine shop vacs also have a coolant fan. Coincidentally, they're both in Germany. They're both
I've
great.
heard this comment from a lot of people about making sure that your shop vac has a cooling fan. But I've used just a Home Depot rigid shop vac, and this is a regular shop vac, and I made 400 signs with it, and I never had any issues with it at all. Not saying that somebody else won't, but if you're not constantly running it and running, if you're just cutting a couple of parts and turning it off and cooling it down, so I can I haven't had any problems. So if you don't have a Festool or a Fine, I would give your own shop vac a try. But
it doesn't hurt to give it a try. Oh, for sure not. What I'm worried about is, and I have to tell you this because as an employee of Legacy and everything else, I don't want to be responsible if you burn the house down because you turn on your vacuum for 12 hours straight. Don't turn your vacuum on for 12 hours straight. You know, it's like a welder. When you're welding, you have the time that you're welding, the time between when you're welding, and so we want to make sure that you're a little bit more comfortable with that one. So you're good using it just that way. Okay, on Ted's vacuum, he has a 1.3 diameter end of his hose, and so we're going to go with a 1.25 hole, and we're going to put it centered on this square right here. So if we bring our cursor over here, after we've typed in our diameter up here, then if we just click, it's going to center it right there for us. Okay, so we don't have to think about where it is or anything like that. We're just going to click. Now we're going to do 4 more holes, and these are going to be the holes that we use to anchor our vacuum table down to the bed of our machine. And so we're going to go with a 1/4 inch hole, and we're going to put it right here. It's going to be an X2, Y2. Now, I'm not good enough to move my mouse to right there very well, so I'm just going to type up here 2 and 2 and click apply, and that should put it right in the center of our hole right there. So now I've got it down here in this bottom section. Now I want to put them in the other 3 corners, and I'm not smart enough at math to do that in my head, so I'm just going to use my Mirror Selected Objects button, this guy right here. And we're going to make sure it says Flip About Job Center and Create a Mirrored Copy. So both this one is checked and this option is checked. When that's checked, we can simply click on Flip Vertical. It's going to put it up here. Flip Horizontal, puts it over here. Flip Vertical again, and it'll put it down there. So we're just going to make it go to all 4 quadrants just by doing the flips on it. So now we have our 4 holes right there. Now, unfortunately, because I left that one selected, when I did my apply, it got rid of that one. So let's put that one back in there. All right. That is all the drawing we're going to do for our vacuum table. So now it's time to go ahead and go back to our toolpaths. So use this button again here on the top to switch to our toolpath command. And we're going to start with this guy right here. So we're going to circle. We're going to use our profile toolpath again. Okay, and we're going to cut to a Z depth. Now, a Z depth is when you type in Z here, it's going to go to 0.75. If you type in Z and then hit equals, it's just going to say 0.75. The nice thing about putting Z in there instead of 0.75 is if you change the depth of your material, say this one's programmed for 3/4 of an inch, but I have 1.5 inch material. If I put Z in here, then when I take this one here, let's just calculate this, and if I were to come up to my material setup and change this to 1.5 inch, like this, I don't know why you'd use 1.5 inch, but just in case you ever did, and then you recalculated it, it would automatically recalculate that hole to go the full 1.5 inch because you're using a variable instead of a depth. So you're saying, give me the full Z depth, and it says, okay, well the Z depth just changed to 1.5 inch, so now my hole is 1.5 inch, and we can check that by just previewing this, and you can see that that hole will cut all the way through right there, even though we changed it to 1.5 inch. If we change it back to the 3/4 of an inch,
you got to slow down because your screens are trying to catch up with you.
Oh, perfect. Okay, so we've changed it back to 3/4 and we recalculate. And if we look at it now, it's reset itself to the 3/4 of an inch thickness. So if you can use your variables when you can, you'll find a much better way to do it. So that just makes it a little bit easier. So there is our profile cutout. We'll preview all of our tool paths. There's our cut, and there's this guy here, and this one's here. Now, the reason why I put this in the corner here, this hole, instead of out here in the center, is because if you're using a small piece, I want you to put your gasket material around this area here, right? To get a better vacuum. More suction in a smaller area. So there's no reason to just gasket the outside edge unless you're always going to be using a larger piece. So totally up to you on how you do that.
Okay, John, I have a quick question for you.
Yes, sir.
We're profiling cutting that hole versus pocketing the hole.
Yes.
So we have to be concerned about that little piece flopping out.
It's going to be 3/4 inches tall by 3/4 inches wide. Mine usually just drop through, but if you want to, you can pocket it out.
Drop through, or the vacuum will suck it up. Okay.
The vacuum will suck it up. Totally up to you. If you
Okay.
want to pocket it for sure. Whatever you're comfortable with is fine.
Okay.
Okay. We're now going to select these 4 holes here, and we're going to do 2 tool paths on them. The first one is going to be just a regular drilling tool path, and we're going to go all the way down through it. So we're going to use our drilling tool path, this guy here. We're going to set our cut depth to Z again, because, again, I want it to work on a variable, not a number. And go ahead and select. We're going to use our same cutter again, that same 1/4 inch end mill. So let's go back to it, end mill 1/4 inch. Okay. So we'll go ahead and we'll just preview those guys like that. They should go all the way through, and they do. And then the last tool path that we're going to do is going to be a countersink tool path. We're going to use drilling again. We're going to set our cut depth to halfway, so 3/8 of an inch. And it's always going to be 3/8 of an inch in this one's case. And we'll go select, and this time we're going to use a 90-degree V-bit. And all this is going to do is this is going to give us a place for our flathead screw to anchor this down to your waste material and do it in a way that the screw heads are going to be below the surface of your material. So let's go ahead and set up that one. We'll do a 90-degree V-bit right there, and we'll calculate that. And we'll preview our visible toolpath there. So here we just have our countersunk holes that are ready to accept your flathead screws. Okay. So this is the vacuum table. This is all there is to it. Now, to build, in our waste table below the vacuum table, we need to do a couple of things as well. If we're going to screw this thing down, I personally really like these guys. We're going to go switch screens over to the internet, so we'll wait until you catch up, and we are going to use these threaded inserts. You don't have to use these by any means. Can everybody see this screen now? This Amazon screen? Okay. These are fantastic. They're brass, so if you do run into them, you're not going to destroy your cutter. And they're just an easy threaded insert for wood. They do a great job. You can take it off and put it back on. You don't have to worry about your drywall screws eventually stripping out and not holding down good. They're wonderful. And you can see here as the picture gets a little bit bigger, here they have some threads on the outside, and then they have a 1/4 thread on the inside, which is coincidentally why we drilled out a 1/4 inch hole there, so it would thread right into this. Okay. Then this is your little tool that is going to help screw it into your waste material, which is great to use. Much better than trying a flathead screwdriver. I've done them both. The flathead screwdriver is terrible. This is much better. All right. So let's go ahead and set up our tool paths for the bed of our machine. Now, most of our machines are going to have some type of a waste material on there or a bed material on there. Some of them are aluminum, in which case I'm going to leave it up to you to anchor this thing down differently, and you won't need these holes here. You're probably going to clamp this thing into your T-track table and mounting your vacuum might be a little bit different. Others are going to have MDF as their base table, and that's what we're going to use as our our table beneath this. And so we're going to go ahead and work off of that. So we're going to take these 4 holes along with this hole here, and we're going to right-click and copy them. Then we're going to open up a new version. We're going to create another new file, 2424 3/4. Perfect. And now we're going to just paste them. So here they all are. The next thing we're going to do is we're going to change the sizes of these holes. I know that these 4 holes need to change to 3/8 of an inch to accept those threaded inserts. So I'm going to select all 4 of them, go up to my gadgets here, and if you haven't downloaded the gadgets, I'm going to show you a really cool website. Definitely want to get in there and download some of these gadgets. But there's a great tool called Circle Resize. So we can click on this one here, and we can say, I have a 1/4 inch circle, and I want to resize them to 0.375. Go ahead and click on OK. It's going to tell you that 4 circles with a 1/4 inch were changed to 3/8 of an inch. And you click OK, and these are all now 3/8 of an inch circles. So with those ones all set out to 3/8 of an inch, now we can put this into our waste material. Now, being that I like my machine a lot and I like my router bits and I'm kind of a cheapskate, I don't want to run my cutter into my metal frame of my machine. So when I cut out these holes here, I'm going to use the profile toolpath because I'm going to use that 1/4 inch bit again, and this is a 3/8 of an inch hole, but I'm only going to cut down 5/8 of an inch. That's the height of those brass inserts. I'm going to go inside the line, and to make it a cleaner and a smoother cut, I'm going to actually come down here to the ramping. I'm going to add ramps, and I'm going to make it a spiral ramp where it just goes down the whole time. Go ahead and click on Calculate. Let's rotate this up on its edge and look at this spiral. We're going to zoom in on this. Okay. Can everybody see how this thing just spirals in a vertical helix until it gets to its bottom depth and then just stops? Okay. What that does is that's going to be traveling down as it's traveling around in the circle. It's going to give you a cleaner, faster cut, and you're not going to get that burn when you go straight down in and your router bit kind of vibrates over a little bit and you get a little bit more of an oval. You won't get that at all. So you won't have to worry about that at all with these. It's a great way to do it. Let's preview our tool paths. We're going to cut those guys out. Those only go down to 5/8 of an inch. Now, for our hole here, we want to cut so that we have a relief area for that vacuum hose to go up through, but not plug into. We want it to plug into our top board, not this bottom board. And so for it, we're going to use the same size circle. We'll go profile again. We're going to cut all the way through to a Z. And this time we're just going to go from inside to outside. So it's going to make it a 1/2 inch bigger than it was when we cut up that top area. So it's going to go from 1.25 inches to 1 3/4 inches. And we'll click on Calculate. Excuse me. We'll preview our visible toolpath. And you'll cut that one out as well. So that just makes it a little bit bigger. And so that's going to be in your baseboard that you set on your machine. You're going to machine out this. Then you're going to put your vacuum table on top of it, machine out those, and then they'll just screw together. They do a fantastic job. They're really great to use. Now, the last thing we need to do then is we're going to go ahead and we're going to build our spoil board. Now, building a spoil board is kind of a funny thing to do. We think of, well, it's just a spoil board. Why do we need to build it? MDF, and we've all used it quite a bit, so we know that the top layer and the bottom layer of the MDF is compressed and sealed very nicely. We want to take off that seal off of both sides. And so the first thing we're going to do is we're going to go ahead and...
Can I stop you for a second?
Yes.
We're talking about a board that gets put on top of the vacuum table that he just made. So it's not your original spoil board on your CNC machine. You'll have your original spoil board on your CNC, then you'll have this vacuum table, and now what he's talking about is creating another little spoilboard plate that'll fit on top of this
Yes.
vacuum table.
Mhm.
That's the spoilboard that he's talking about.
Yeah, if we don't have that spoil board and we're using this table and we put our workpiece right on top of this table and we cut through it and we cut down into our grid right here, we lose all of our vacuum because now all the air can be pulled through that hole that we just cut. We don't want that. So instead, by putting a spoil board on top of there, we can cut through everything, and you'll be surprised once you put that spoil board on there. You put your hand on top of your vacuum table, you'll feel it suck the cup of your hand, this area right here, down to the table. It'll literally try to pull your hand down to the table with your shop vac. It does a fantastic job. So let's go ahead and build this table. It's really simple. This is one quick tool path. We're going to create another new file. We're going to go another 24 by 24, and this time we're going to go a 1/2 inch. We're just going to use 1/2 inch MDF, and we will draw a square this time that's going to be 25.5 by 25.5. We'll go ahead and click on create. This is our entire drawing for that top spoil board. We're going to go to our toolpath side, select our box, and we're just going to do a pocketing toolpath. So we're going to use this pocket toolpath right here. And we are going to use an 1¼ inch end mill. This might be a new cutter for a few of you. There's a link that Ted's going to send you with it. It comes from a company called Magnate. It runs about $21. It's a perfectly flat end mill, great for surfacing off the bed of your machine as well. Anyway, wonderful little cutter. And we're going to cut down just under a 1/16. I went 0.06. We're just going to take off just that top sealed edge. And we're going to go ahead and just calculate that out. So it's just going to do one of these. If we preview our visibles, you're going to see it just knock off that top surface. We're going to flip it over. We're going to knock off the bottom surface so we have a nice porous piece of material to use. And that is our entire vacuum system. That everything is all built and ready to go.
Okay, let me step in here just for a second again. When I first got into this, I didn't understand this concept of putting a piece of board on top of the vacuum table. MDF is very porous, so you don't really need to actually skim off a little bit at the top and the bottom.
Mm-hmm.
You get air pulling through it, but you get much better air flow through it if you do a little bit of a skim off the top and the bottom. Then it's very porous, and that vacuum works so much better.
Yes. Yep. Okay, now comes the fun part, because all this is just work. Now we're going to use a drag knife. Now, has anybody used a drag knife at all or played with a drag knife at all? I'm taking that as a no. Does anybody want to use a drag knife? Has anybody, thought about using them at all? So Don is saying
I have
yes.
a question.
Yes, sir.
So your very top spoil board, you're counting on that to hold your piece down?
Oh, yes.
So where are you getting the vacuum from?
Okay, you're getting the vacuum.
It's going to pass through the MDF, you mean?
Yes.
Really?
Oh, yes.
Wow.
Okay, I will tell you a funny story about that. Went to England. England's a wonderful place. My boss was over there, and he didn't believe it would work, bet a guy dinner, and ended up owing him dinner because he didn't think it would hold down. It is fantastic. It will hold it down very, very well. There are a couple of great videos on it, but yeah, once you do this, you'll be just blown away. Now, will it hold down a piece the size of a quarter? No. Will it hold down one the size of the palm of your hand? Yes. That it will hold down. It doesn't need a lot of force. Yeah, now you're a 1/2 inch thick MDF, and you're going to take off those two sealed edges, and it's wonderful. Mm-hmm. Yeah.
Well, it seems to me
I
you
got a question.
Yes, sir.
How do you attach the vacuum to the bottom side if that's sitting on your table?
Okay, that is fantastic. So what we did is we actually cut a hole through our waste table, so through our base table in our CNC machine, and that hole is large enough that the end of your vacuum will go through it without plugging into it. And then this one here has a hole, and we built this one for Ted's vacuum, which is a fest tool, and it has a 1.3, is it 1.3? 1.35 diameter on the end of it. And so we made this one a 1.25, so that when you shove it in there, it's just going to friction fit in there. You don't want to glue it in case you want to use your vacuum for something else. So just snug enough in it that it'll hold. Then when the vacuum comes on, it's going to make it hold even more because it's pulling all the air through there and it's trying to find places for it to escape. So it actually holds itself in as well.
One more question.
Yes, sir.
It appears to me that you must use a vacuum with a high volume capability, and that would not work if you were to use, say, a high vacuum, low volume, as if you were going to use a vacuum chuck on a lathe.
Exactly right. Yes, there are two kinds of vacuums. There are the vacuum pumps, like the high vacuum, low volume, like on a lathe, and then there's a blower style. This is set up for a blower style. The idea behind a blower style is that it's just pulling air through. Like when you were a kid, you remember putting a piece of paper on the backside of one of those square fans?
Sure.
And how it would hold that against the back of the fan all the time? You know, there wasn't any vacuum there, but it was just that air pressure as it was pulling through. It was moving all that air and holding it against that fence. Essentially, that's what we're doing here. The reason that we prefer this over a pump is if you pierce through the pump in that sealed area, we lose all vacuum. And so the puck system, the puck style, which is that high vacuum, low volume, is great for secondary operations as long as you know you're not cutting through what you're doing. But on cutouts and things like that, then the blower style, this suck down through, is a much better system.
Okay.
So Vince and others, just about any shop vac will work for this.
Mm-hmm. Yeah.
So you can use just about any of your shop vacs. This system will work.
Yep.
I have a question.
Yes, sir.
On my machine, I have it's aluminum, has the slide rails on it.
Mm-hmm.
How would I hook that vacuum up to this board?
That is a good question. If you have the aluminum rails, there's no area that's not aluminum on the base of your machine, right?
Exactly.
Okay. Then what we're going to have to do is we're going to have to build this board, but you're going to actually want to build a box. So we're going to want to build a box that's just a little bit bigger than the diameter of the end of your hose, so that you can then mount that whole box up on there and plug your vacuum in from the side.
Okay.
Just so that you can lift it up. Now you're going to lose a bit of Z height on there,
Right.
But the only other option is if you can hang the front of your vacuum off the front of your machine, because once you plug this in here, you're going to equalize the air pressure across your entire board. So you could technically hang this off the front of it, and then just cover the front area of your waste board in with a plastic sheet, and then use the back edge of it to cut. But either way, it is gonna add an additional challenge for you for sure.
Okay.
That's a great question, though. Okay.
Later on, I can probably put a picture up of a box system like that.
Mm-hmm. All right, let's go to the drag knife. Now, we're going to switch back over here to the internet again. The Cosmos Industrial. This is a... Okay, we'll let it catch up. It's got to catch up on my end itself as well. Okay, so this is the drag knife. Now, the Harbor Freight $20 shop vac works great for this. Hey, and it's only $20 if you burn it up. Woo! You know, not a big deal. That's a very good point. So Jim is just letting us know that the Harbor Freight shop vac works fantastic. Okay, so this is the drag knife tool. Now, this notice just came up that the product has been discontinued. Please see our other CNC accessories. So this is the one that Ted uses, and it's a fantastic tool. Because it's been discontinued, I'm going to show you another one. It's a little bit more expensive, but we have the ability to get it. It's going to be this Donic drag knife. A little bit different tool, does the exact same thing. So it's and that's terrible that it's been discontinued, because that is quite a bit cheaper actually. If you purchase these ones, these are more like 175. That one's 135, so much less. Now, 239, so it even went up. Now, if you're part of the Kalamazoo woodworker, oh my gosh, makerspace, I bet you there's probably 5 or 6 guys who can probably 3D print one of these for you, or at least show you how to 3D print and make one. So what's important about the drag knife is just understanding a couple of things about them. And so we're going to go back here and we're going to just draw a profile of a drag knife and talk a little bit about how they work. And then we're going to set up, and we'll do a couple different shapes. And then Ted's going to send you a file that actually has, you know, a lot more detail in it. So we're just going to create a new file. We'll make this one like a 10 by 10. And thickness doesn't matter, because we're just going to talk about what a drag knife is. Okay. So if we were looking at a drag knife from the side profile, we have, of course, that 1/2 inch piece that's like so. It's not even 1/2 inch, so just bear with me. I'm not a very good artist. And then we have its body and everything else. And then below that, we have, coming off of the center line, we have the tip of the cutter. And if we're going to go like this. So our cutting edge is behind the center line. What we have to know is how far our cutting edge is back from the center line. Because when we cut, we have to over travel to actually get this thing to cut to the center of our part. We have to over travel by this linear distance right here. Okay, does that make sense? So for instance, if I wanted to cut this line here, if I took this guy and I plunged down on center, I'd be plunging down right there, which means I'd actually start behind it, right? And then if I traveled over to where my center line finished off the line, I would stop here, which would stop me behind it. So when you do a drag knife, you need to know that your blade offset, which is just how far back off of center is your blade. Now, for this one here on the Donic tool, we're going to go back to our website here. We can go up here to compare our drag knife models. And it's going to give you, okay, it's going to give you this approximate offset value of 0.065, 0.16, 0.065, 0.16, and 0.08, or 0.8. This is important because this is how we're going to set up when we do our tool pathing, how it's going to act and what it's going to do to react. Now, the other thing that we can't do, our blade is straight, right? Like any knife blade. So if our blade is straight, but we try to push against the flat of that blade, we're just going to snap it off, right? So what we have to do is we have to make sure that when we set up our drag knife, that we set it up in a way so that when it makes its first cut, it's always traveling in the direction that that knife last ended traveling. So I'm going to show you how Aspire actually does that all for us. It's very, very cool. VCarve Pro, they both do it. It's wonderful. So we're going to go back here to our Aspire, one more toolpath, or one more drawing. We're going to create our new file. We're going to stay inside of our 10 by 10 just because it's already there. And we're going to grab a square. We'll put it right here. Just any size square. We're going to grab our star. And we're going to grab a 5-pointed star, like so. Okay. And then we're going to grab a circle. And we'll put him about right there. Okay. Now let's put a drag knife toolpath on each one of these. So we're going to start by just selecting the piece that we want to put our drag knife on, and we're going to select all 3 of them. Important that you select them in the order you want them cut, because that is the order that it will cut it. This is a manual vector selection order, and it will force you to do that. We're going to go up here to our gadgets up here in the very top. We're going to go down to our drag knife toolpath. So go ahead and click on select. Okay. Now, this is the big warning in red. Make sure your spindle is turned off. Unplug it if you must, just don't turn it on. It does fantastically magical things to drag knives when you leave your spindle on. Like it blows your bearings. I've wasted $239 doing that, so don't be John. Be smart. Okay. Second thing, know your cut depth. So if I'm cutting through rawhide runs right about 0.15 thick. And that's what I do all my knife handles out of. My swivel depth, this is when you have a router and you're cutting with your machine, you're cutting out the square, then you lift up, you go over and you cut out the star, you lift up and you cut out the circle. You have a Z height that's above the material, right? This swivel depth is exactly the opposite. It's how far are you going to stay in the material when you change directions with your cutter. So it's almost like that safe Z height, but backwards. So I'm going to tell it to stay in there 0.01 inches. On my leather, that works wonderful. Now you're going to decide that on your own, and then you decide what you're going to do. Now what it does is it's going to retract almost up out of the material, and then it's going to make a loop so that it puts itself in the right orientation to then make its next cut. And then we decide how many passes to get to our cut depth of 0.15. Now, depending upon your tool is going to tell you what is your maximum cut depth. So I have the D2, and that will cut up to a 1/4 of an inch thick, so I'm going to do it in one pass, no big deal. My blade offset. Now, this is what we talked about earlier. How far off of center line does that tip of that blade? And so we're going to say a 0.06 because that's what it is. The tolerance angle means I can bend a 45 without lifting up and coming out, but anything more than that, I want to lift up, make the rotation, plunge back in, and cut. The last thing you have to do is you have to make a dummy end mill. So I always go in and I select a tool, and I'm going to put the spindle speed on that tool at 0. So then even if I forget, I know that it won't turn on. So I'm going to grab my end mill 3/8 of an inch. My spindle speed is going to be at 0 RPM. My cut speeds, I'm going to do at about 60 and 30 is where I found I'm pretty happy with. This pass depth does not matter at all. Apply and OK. And now I've got this one set, and I can go ahead and say tool path name is my drag knife. Click on OK, and we have our piece. Now, let's look at what it did. You can see this right here. It travels 0.06 beyond, so that the edge of my blade cleans it up right there. Then it does this little swing, lifts up, plunges down. And when it plunges down here, the edge of my blade is actually back here. Because again, that's that 0.06 offset that I have. So on each of these cuts, it's going to do that. Now, if we go into our 3D view, we can also see how it's going to work. It always, always, always travels from left to right on its very first cut. So it's going to ask you to orient your blade so that your blade is pointing to the right. And that way, when it plunges and makes its first cut, it can then lift up. And if we look at these, you can see how these kind of look a little bit weird. Go to this one here. See where it lifts up, makes that little hoop, plunges back down, and goes back to work. That's again that place where it lifts up almost out of the material, rotates around, and cuts again. Okay. And so it'll do that on its fourth side. It doesn't need to, but now it knows that it's pointing south. And so if you look at where it comes into my star here, it's going to start here pointing south. It knows that it has to make a loop before it can go on to here and then continue making those loops all the way around. So it's going to continually readjust itself, and it knows where it ended, so it knows how to begin. So they've taken all the hard work out of it, thankfully. And if you look at our circle here, we can see here on this one that it starts here, presets itself, loops around the circle, and then finishes out the program. So thankfully, they've done all the hard work for us. It's just a matter of us cutting it. Any questions about this portion of it? This is a pretty cool portion, but man, I tell you what, once you break your first razor blade, it opens your eyes a little bit. Say, oh crap! So, any questions on this portion? Everybody's pretty solid.
Question. Where do you set your Z? You don't use any kind of a touch-off plate. You just like, say you're cutting that Coroplast plastic sign material. You just bring it down to the top of the sign material and hit 0. Just guess what place you are.
When I set my Z, when I'm doing all of this, I set it off the base of the table. So I'll set it before I put my rawhide on there, because rawhide is not flat at all. It's terrible. You'll go to set up and you'll set it on the bed of the material. Yeah, Z on the bed of the material. Yes. Yep. Okay, and then Tom asked a question of how does the blade rotate to a new direction? Let's show you that here. Let me get rid of this toolpath, and we're just going to do the square. And so we'll go back into our gadgets. We'll go to our drag knife. Here's all of our cut depth. We're going to go back to 0.15. Everything else is fine. Go ahead and click on. Okay, so Tom, the very first thing it does is to set up, to make it rotate, the first thing we do is this swivel depth, this guy right here. This swivel depth says, when I lift up out of my material, I'm going to lift up, but I'm going to stay in the material. This is 0.010 of an inch. So it's not quite coming all the way out of the material. And that way, when it makes that loop, it will turn the blade through that loop, because the blade is still going to be just barely in the material, just enough to let your ball bearing spin that blade around to the right direction. Perfect. Okay, and Tom says he's got it, so he's solid. And you can see that on each of these. It turns in, and then turns back in again. So each of these angles, as it brings it around, it's going to force it back to the right direction. Okay?
Can we preview that?
Yes. Now, it doesn't preview very well because it's...
Slow down your speed when you
Let's
preview.
do that. Okay, let me turn my preview speed all the way down. And we'll just do preview selected toolpath. God, that's still really fast. 1 second here. Let's see if I can slow that down some more. And we'll do the one with all of them. And we'll play. Oh, go. That's still very fast.
Real fast.
Yeah. You're going to get a file with all this on here. But you can see in here, you can, now again, this is 0.010 of an inch, so it's just barely nicking the surface. But it's just enough that it'll make that blade change its angle and turn, to be ready for the next cut.
So what actually happens here is, like, say if you wanted to cut out your own custom cardboard box shape, make your own custom box. Take a piece of cardboard and put it out there and cut it. What actually happens is the blade takes the material and damages the material outside of the area that you want saved.
Yep. That's perfect. Okay. Any questions about any of this?
So if you're doing this on your vacuum table, wouldn't you lose vacuum?
No, that's why we do that waste board above there, because we're just cutting a line in there. So not enough to lose any vacuum at all. In fact, even with a 1/4 inch cutter and you cut all the way through a part, you're not going to lose any vacuum on it as well. But doing it with this, you're going to lose almost no vacuum because you're literally just cutting a slit, with the razor blade. So you'll be fantastic with it. Great for leather work. Oh, it's fantastic for that. But you can use this for cardboard. Again, that we buy it at the dollar store. It's this 1/4 inch thick. It's got 2 sheets of poster board and then foam in the middle. It's fantastic for modeling. making stuff. We did my son's science project on it. Really fun to play with. But anyway.
Yeah, a lot of guys use that to make model airplanes.
There you go. Yeah.
You know, like paper airplanes. Mm-hmm. They'll go to the dollar store and they'll get that foam board.
Yep.
And then they cut it with the drag knife.
Mm-hmm. Cuts wonderfully well. So really, really cool stuff. Okay. Any other questions on this stuff up to this point? Okay. Jim, what is the cut speed again? I use on my cut speed about 60 inches a minute. Now that's going to be relative to if you've been using the same blade for a long time, slow it up a little bit because your blade's getting dull. In the leather, about 60 inches is really good. That's pushing it a little bit. If you want to go down to 40 or 50, you'll probably be a little happier with it. But I've been very happy at 60 IPM on the cut speeds. Everything again depends upon your router or your machine itself. If the machine doesn't like you going 60, slow it down. It's not going to hurt anything. But I've seen them run a lot faster. I've seen them run a lot slower. It's just kind of whatever you're comfortable with. You can always start slow and increase as you get more comfortable. Which is easier on the heart than starting really fast and slowing down when your heart lands in your throat. So never a bad idea to start slow and then kind of walk up into it. Won't hurt at all. All right. Let's see here. Beyond that, really, we're just open to any questions, drawing in general, anything that you have questions on.
The vinyl cutter?
Oh, yes. We're going to have to kick it back to you on that one because you sent it to my cell phone. Do you have a way to get that up there? Yeah,
I do. We have the website link. I'll take control and let me see if I can find it. Here it is right here. I'll take control back and I'll put it up.
Pass presenter role to you.
Okay. So
there we go.
So can you see my screen now?
Mm-hmm. Yes.
Okay. So this vinyl cutter right here, this is a little tiny needle, and let me see if I can. You see how small that blade is right there? Mm-hmm. It's like a hypodermic needle, and this whole thing. Let's see how I get back to smaller picture here.
Just hit the back arrow key in your upper left corner.
Back arrow key. Did I get it down? No.
No, upper left corner of your screen.
Oh.
Yep.
No, I didn't get it. That got me out.
Oh, that went all the way back.
I'll go forward again. There we go. So $9.99. I ordered this, and it came by regular mail, and it was here in 2 days. And so anyways, what happens is this is spring-loaded, and that needle bounces up and down on your vinyl to cut the vinyl out, and it works really well. So I cut out some poster board the other day, and I was just very impressed with how well it had cut out the poster board. So the problem was mounting it, and I made a mount. I'm not sure if I did it right. If
it worked, you did it right, man, and it worked. So must have done it right.
Yeah. So let me bring this picture over. Oops. This is how I mounted it on my machine. I've looked at other pictures, and they don't have. Let me see if I can bring this down a little bit. You see this little pin on the top? It's got a spring, and it's spring-loaded so that when it rides up and down, it bounces up. There's a magnet in here that holds this cutter, and that's what allows the cutter itself to spin. But what I did is I put pressure on that pin by making, I cut two little buttons on my CNC machine out of Delrin and put a spring in there, and then you can see the cutter here, and then when it goes down, it's spring loaded and it bounces up and down. Whoa! That was my back door. It was spring loaded, so that worked out really, really well. So I just wanted to show you that. I'll put a link. This is the name of the company, D1 Engineering, and it's really difficult to find it on their website. So I just went into the search box and you type drag knife, and then it comes up. So if you guys, and it comes with 3 blades. So for $10, you guys can get yourself a drag knife. And if you go into Thingiverse, there's about 10 or 15 different mounts for all this kind of stuff. So you can, find somebody that's got a 3D printer and have them printing out one. So that was one thing that I wanted to show you. Another thing I wanted to show you was a plotter that I made. And the plotter works really great too.
Yeah, I think it's awesome.
This plotter here, it's sideways, right? This part here mounts into your spindle. And what I ended up doing is I let this thing spin around. I didn't put that bolt in there. But I think I'm going to put the bolt in because I think it'll work better if it's fixed. But anyways, my old one, I had a spring. Here's a picture. My old one, I had a spring in here. But this is a 3D printed part. And actually, a friend of mine said that if anybody wants one, he would print one up for $20. But there's a whole bunch of designs on the internet that you can get, and the files are free. And if you know of anybody, like a makerspace person, they can, you can go to a makerspace and pay them, and they'll print it up for you. But this really works out great. And I'll tell you, Don Bates over in Kalamazoo, if you just call them, I'm sure they print it up and mail it to you.
One thing, Ted, on Thingiverse, it said that you should use ABS to print it rather than PLA.
Yes. We printed the first one up using a PLA, and it turned out terrible. It was really, had a lot of holes, and it wasn't even a very clean or good-looking part. We changed and we printed it up with ABS, and this part turned out perfect. There's not one hole in it, and it's solid plastic, and it really is good. There's lots of spring in it, and it works really well. So let me just tell you 2 applications. I've got several times I've had people come to me and ask me if I'd cut their instrument panels out of aluminum. So what I've done is I've taken a big sheet of cardboard and I put it on my table, and I'll put this plotter on here, and I'll draw all the circles and all the holes that I'm going to cut out, and I'll give the part, I'll even draw the outline of the shape of the panel, and I'll give it to the guy, and he'll take it back, and he'll take that piece of cardboard and stick it in his airplane, and he'll know if the holes are in the right spot and everything else. So that's really, really helpful. The other thing now that I can do with the drag knife, and I didn't use the drag knife that has the knife on it, I used a vinyl cutter. And I used it, and I cut poster board, and I cut it all out, so all the holes were all cut out and everything in cardboard, and I gave it to the guy, and he checked it out, made sure it was right before I cut it out of aluminum.